What if the iconic equation F equals ma, which we've known since childhood, holds a much deeper meaning than just a simple calculation of force? What if this formula is actually a window into the way the universe itself accounts for and responds to changes in movement? In this episode, we're going to explore F equals ma not as a mere mechanical tool, but as a fundamental rule embedded in the very fabric of the universe, specifically through the lens of energy filament theory. Let's begin with acceleration A. In classical physics, acceleration is often defined as the rate of change of velocity. But in energy filament theory, acceleration is much more than just that. You can think of it as a command that alters the rhythm of a structure. Imagine a system moving along a predetermined path, everything in perfect harmony, moving steadily. Now, when you apply a force to accelerate it, whether that's making it go faster, slow down, or change direction, the acceleration command is forcing the system to change its established rhythm. The more intense the acceleration, the more drastic the change in the system's movement pattern. It's like changing the tempo of a song suddenly. It's not just a small shift but a complete overhaul of the system's flow. The more rapid the acceleration, the more difficult and costly it is to change that rhythm. And this is where force F comes into play. Now, let's talk about mass m. Typically, we think of mass as just the amount of stuff in an object. The more mass, the heavier the object. But in energy filament theory, mass is more about how deeply the structure's texture is embedded within the surrounding energy sea. You can imagine mass not as a simple object, but as a complex structure that is either lightly or heavily intertwined with the energy around it. Let's use an analogy. Think of an object like a small piece of thread floating in water. When you apply a force to it, you don't need much effort because it's lightly connected to the energy. But if you think of a coral reef firmly rooted in the sea, it takes much more effort to move that structure because it's so deeply integrated with the surrounding energy. The more mass an object has, the deeper its connection with the energy sea, and the more force you need to move it. When we push a small object, it's like pushing a piece of wood floating in water, where you only need to disturb a small portion of the water's flow. The object moves easily because the structure isn't deeply embedded in the surrounding field. However, when you try to push a large, complex object, like a whole system or even a large ship, it's not just about pushing the object directly. You're disturbing the underlying structure's deep connection with the energy sea. It's like trying to move an entire marching band in sync. They aren't just individual people, but a coordinated structure of motion. Moving them is much harder because you're disrupting the natural flow of that system. In simpler terms, mass is a measure of how much the structure is tangled up with the surrounding energy sea. The more entangled it is, the harder it is to change its movement. And here's the real insight. F equals ma isn't just telling us that force is proportional to mass and acceleration. It's telling us that to change the rhythm and flow of a structure's movement in the energy sea, we have to pay a price. This price is forced. The bigger the object, the greater its connection to the energy sea, and the more force is required to change its path. This is the hidden cost we're paying when we try to make something move. This brings us to the real meaning behind F equals ma. Every time you exert a force, you're not just pushing on an object. You are negotiating with the energy sea. You're telling it how fast, how violently, and how broadly you want to change the object's movement, and the energy sea charges you for that change. The force you feel is just the cost of rewriting the rhythm and pattern of the structure's movement within the vast sea of energy. Looking at F equals ma in this way, it stops being just a simple formula we memorize and recite. It's actually a universal law, a rule that governs how everything in the universe moves and how energy is distributed. The universe is constantly balancing energy and motion, and F equals ma is the shorthand for the accounting system that dictates the cost of those changes. It's not just about physics, it's the language of the universe's movement, energy, and rhythm. Next time, we'll dive deeper into the concept of inertia and explore why it's so stubborn. Why do objects resist changes to their motion? And what does that really tell us about the universe? Tap follow, share it on New Physics, Clear Universe.